It will open a browser window. Minimize it or look at the taskbar. Command को run करने के बाद ये browser window will open. Bottom में check करो. You will see a window glowing. Desktop documents, wherever it is, you can go and get to the data. So I forgot the water bottle. Hostel has AC, right? Generally, we have ACs, no? 10,000 per month. Okay. For 1 month, same. No, it's hot. Very hot. Very hot. 1 month you can pay 10,000. March it was horrible. That is Thar desert. Desert is my friend went to Datascience, Missouri. There also it is 35 degrees. Night it was hardly 10-12 degrees. Offsite meeting, they are saying nothing. They went to investigation. In daytime, they got so drained out. They are saying we unnecessarily went. We were this. Yes. Okay. Now, so this is the data we have. House train, sorry, STR of house train. So you can see there are int variables, there are categorical variables. There are int variables and categorical variables. We have a lot of variables in our data. STR house test. You remember the STR is like will give you the structure of the data and individual variable data types. STR. Info is in Python. You get all the things. Structure of the data frame and as well as the individual variable data types. Okay. So now, if you remember in this data, what we have done is this data has missing values. The major issue is missing values in both numeric and categorical variables, right? So remember, we have missing values in both numeric and categorical variables. So start open bracket, call sums open bracket, is dot na open bracket, house train, sorry, come out of two brackets, decreasing is equal to true. Now you can see the missing values in various columns in decreasing order. Full QC, miscellaneous feature, alley, fence, fireplace quality, lot frontage, garage type, garage ability, you have many missing values. No, we combine them. We have to check. Sort, call sums, is dot NA house test, comma, decreasing is equal to true. I think similar columns have missing values in train and test data. And some extra columns have missing values in test data and train data, but most of them are similar columns. All right. So what we will do, we will combine both data frames for pre-processing. We will combine both the data frames for pre-processing. What is the function? R-bind, row binding. R-bind is a function which will first paste the rows of the train data set. Below it, it pastes the rows of the test data set. But for this to happen, the number of columns should be equal. But we have a dependent variable in train data. We don't have it in test data. We will minus the dependent variable and combine both the data frames. So combined DF is equal to R bind open bracket house train square bracket comma minus 81. That means you are ignoring the dependent variable comma house test. So once you say minus 81, it will not take the 81st column, which is the dependent variable column. Both will have 80. It will do the combined DF. Now you can see here, combined DF is 2919 observations of 80 variables. In the data environment, you can see it as 2919 observations of 80 variables. No, we cannot do the C bind. Then we have to use merge or join by left or outer like this. If there is column mismatch also, if the column names are mismatched, that means here the column names are same. So we can simply use R. If the column names are mismatching, then we can't do R. Then we have to use what you call merge or join with a common column. With a common column, you can do join or merge. Okay. That is risky because if at all you do something different on test, which you have not done on train, again it will be problem. You can do it separately. You can do pre-processing separately on train and test, no doubt about it. But you have to do the same thing what you have done on train and test. The same levels should be what you call done on the train and test, categorical levels. If at all a new categorical level is created in test, then your whole model will say new level form not built. Now that problem will not exist in Python because in Python the new levels will be added to the memory automatically. But in R you have to manually correct the levels, which will create problems. So it's always better to combine and then do the pre-processing so that we don't make them errors. Now check the missing values on the combined data. Sort call sums is.na combined DF come out of two brackets decreasing is equal to true. All right. Now, if you observe the missing values in the first tag, if you remember in Python, we have imputed them as none or missing value because there are too many of them. If there are too many missing values, we cannot impute them. So we will impute them with the word missing. So we will do the same process. Right. So missing calls is equal to, we'll create a vector C of single quotes, full QC, you can copy from down console, comma, single quotes, missed feature, comma, single quotes, alley, comma, single quote, fence, comma, single quote, fireplace queue. Please be careful with the column names. They should exactly match. Okay, so we're good. Yeah. So combining here, square bracket, missing false is equal to yes, apply, combined here, square bracket, missing false, comma, missing, comma, missing. Okay, one second. Okay, it is not taking 1 second. We have to write a loop. For call in missing calls, curly brackets, combined here, square bracket, as applied, combined here, square bracket call, comma is dot na is equal to missing. Sorry. Loop is not running properly. For calling whisper, combine here square bracket S apply, combine here square bracket call is dot na comma call or else message. This is the loop. Be careful with the indentation. First, create a vector called machine calls and then run the loop. Curly braces. So we're imputing more than 70% missing as missing. All right, all of you have imputed the missing values. Okay. Now we will split data into character calls and numeric calls. We have to split the data into character calls and numeric calls because the imputation methodology is different, right? So for the purpose of imputation of data, we need to split the data into character calls and numeric calls. Now we have this library called tidyverse where we can do like select underscore d types in Python. We have in Python select underscore d types, right? So same thing we have in our under library tidyverse. Or you can write a simple sapply function. Sapply function will also do it for you. Okay, so I will do the sapply function. THR calls or character calls is equal to combine df square bracket s apply square bracket s apply combine df comma is dot character. So this should separate the character calls. So on the right side, if you see on the right side of the data environment, you can see 2919 observations of 43 variables. Similarly, same code, num calls, numeric calls is equal to combine df square bracket s apply. S apply is row apply, L apply is column apply. Combine df comma is dot numeric. Is dot numeric is a function that we apply on numeric calls. So we have 37 numeric calls, we have 43 character calls. Shall we use mice algorithm here? Like I told you, we have this mice algorithm to impute the missing values. So for that, call names, numeric calls. We have to identify from the num calls, what are the character calls? From the num calls, we have to identify the character calls. So what are the character calls? Overall quality, overall condition, year rebuilt, year built, and year remodel. They are all categorical calls, right? Categorical call means within the numeric columns, those variables that cannot be treated as numbers, that has to be treated as categories, particularly rating scales. Overall condition and overall quality are rating scales from 1 to 10. 1 being worst, 10 being best. Similarly, years. Can we treat years as numbers? We cannot. Because we can't calculate the mean of years, we cannot calculate the median of years. So we have to identify. So let us identify those characters. Cat calls is equal to C of overall quality, overall conditions, year rebuilt, and year remodel. They are all simultaneous columns. You can copy and paste them. Control C, Control V. You have to add commas to them. Comma. Year remodel, comma. Any other garage year built. Garage year built. So these variables, we need to treat them as categorical calls. Or we will separate them. No. Let us do one thing. Cat calls is equal to num calls square bracket, comma, C of column number 5, 6, 7, 8, and then column number 25, 26. Right? 5, 6, 7, 8, and then column number 26. This is 25, this is 26. We are separating them into cat calls. So cat calls is 5 variables. Now we have to remove the same from the num calls, right? Num calls is equal to num calls square bracket comma minus c. You have to select these columns. Now very carefully you put minus before and run only once. You have to run this negative indexing, make sure you're running once. Otherwise it will repeat, delete the other columns also second time. So I am running it only once. So now we have num calls 32, cat calls 5, and character calls 43. Total is 80 calls, right? Is this calculation right? We need to have 80 calls in our data. We need to have 80 calls in our data. So we need to make sure that the sum total is 80. How did I get them? I got them from 32, 5, and 4. What? Which calls? What are those? You are saying within num calls. Num calls are all numeric only, right? Oh, years old we forgot, yeah. Years old and months old we forgot. Oh, sorry. $31, $32. So I will redo the columns again. Comma 31, comma 32, comma 31, comma 32. So I will split the data again. Okay. Numeric calls, then cat calls, numeric calls. Got it. So 37 and 43. Years old and months old are also categorical, right? Years old and months old are also categorical. So run from 18th line. First run from 18th line, 19th line, then run these lines. Last two columns. Numerical also cannot capital, right? Oh, we got a mistake here. Yeah. Got a mistake. One second. Yeah, sorry. 36, 37, right? Yeah. Okay, now it is correct. So 36, 37. So if we convert anything with as dot factor, will NS will be there? Let us see one column. What is the column? Plot frontage. Character calls dollar lot frontage. Why there is no lot frontage in character calls? Can you get actually why? They're there. Why need to attach? No, no need of attachment. That is old history. I think lot frontage is a numeric calls. Attach అనేది నేను నేర్చుకునేటప్పుడు almost 10 years back command అది. ఇప్పుడు no need of doing any attach. Num calls dollar lot frontage is equal to as dot factor num calls. Oh, we can't convert it into factor yet. Shit, why am I doing this? In character calls, what are the missing values? We have to find. Character calls garage call. Let us take garage call. As dot factor character calls comma garage call. Table character calls dollar garage call comma use NA is equal to always. Yeah, NA is being retained. Yes, once we convert them into factor, NAs are still coming. Right? So what we can do is, let me just make sure. Now, character calls factor is equal to L apply character calls comma factor. STR character calls factor. Everything has been changed to factor. Cat calls is equal to L apply cat calls comma factor. What is this factor? What is this factor? No. This is dummy variable encoding. Factor is nothing but label encode or dummy variable encoding. I think missing values are written. Sort all sums is dot name character calls factor comma decreasing is equal to true. Data dot frame character calls factor is equal to data dot frame character calls factor, convert it into data frame. Okay. Similarly, cat calls is equal to data dot frame cat calls, because they are in array format, so converting them into data frames. So remember, the factor is label encoding. Factor is label encode in Python. What is label encode in Python? Dummy variable encoding. Same thing in R, we call it as factor. So the word factor will convert the categorical variables into numbers by assigning numerical identifiers. That is what we will do in factor. Now, once we apply, it becomes a vector. So we have to convert vector into data frame. We have to convert vector to data frame. Here also, we are converting vector to data frame. Convert vector to data frame. Here we are separating category calls from num calls. We are deleting category calls from num calls. Here we are splitting the character calls. Here we are splitting to numeric calls. So factorization is label encoding or pd.getDummies in Python. We have two things, right? Same thing here. We are doing it in R. Got it, all of you? Once you're done, please confirm. Okay, can we move? One second, I'll start it. Now we will combine all data frames into one. All data frames into combine df underscore full. Okay, we will combine all the data frames into combine df underscore full. Combine df underscore full is equal to c bind numeric calls, num calls, comma, character calls, factor, comma, cat calls. Now we have combined them all into one single data frame. Library mice. Imp is equal to mice combine underscore df underscore full. Correct, huh? You tell her what is the error. Shit. System is computationally singular, reciprocal condition number is there. 1 second. Comma, method is equal to PMN. Reciprocal condition number. What is this error? 1 second. So we are using decision tree as the imputation method. So complete is the command, we'll convert it into the best data set. Okay, then we are splitting the data back to train and test. Then we have added the dependent variable back to train data. We deleted it, right? దేంట్లో దేని సమ్మరీ వేస్తున్నాను కరెక్ట్గా చూడండి. నాకేమైనా చూపించట్లేదే. ఎన్ఎస్ చూపిస్తాయి అవి ఉంటాయి. దట్ మీన్స్ ద మోడల్ ద వేరియబుల్ ఇస్ థ్రోన్ అవుట్ ఆఫ్ ద మోడల్. Some variables will be there which will be thrown out of the model, like this total basement SFP, it is thrown out of the model. It is found totally not significant by the variable. Same thing, ground living area is completely insignificant. You can remove those variables. Wherever you see any, yes, you can run it. Yeah, you want you can run Python. So total basement life ground living area completely of no use. Completely no use. This is you can select now. I think all electricals are no use. Heatings are all no use, except one, and that too 0.05. All heatings are no use. All heatings are no use. You can delete them. Similarly, all basement fin type ones, most of them are no use. Type 2s are all no use. Tier 2s are all no use, right? Because their p values are greater than 0.05. So you can see from here and you can remove them, right? And what is the sync off? Sync off, huh? How to off sync?
Sync off.
Sync net off cheyali, otherwise it keeps on running. Sync off cheyadamana direct. Because I don't want it to run, otherwise it will run for pages and pages. Where is it? Data folder. Date modified. Hey, where is my file? నా డేటా ఫోల్డర్ నేను చేశా కదా. I'll close it and reopen it. What happened? Where did my file save? ZWD. Data folder. Okay. Not all folder, data folder. Okay. Went into data folder. Desktop data. Here. R regression 2020. Write.csv. Can do that. See, don't assume anything. Assume chala chestunnadu. Don't try to overthink and assume. Okay. మీరు చేయాలనిపిస్తే చేయండి. If not, go with Python. That's all. You ఆలోచిస్తూ కూర్చుంటే it will never end. It will be a never-ending process. ఎందుకంటే better to do something. This is estimate. This is estimate. This is standard error. P value PR greater than T. So దీంట్లో మీకు కావాలంటే you can do color coding. మళ్ళీ ఇక్కడ మారింది ఏంటి? Yeah, hello. Third floor reception లో ఇచ్చేయండి. ఇది కేఫ్ ఎక్లాట్ బిల్డింగ్. మీరు ఎక్కడున్నారు? టెలికాం నగర్ బస్ స్టాప్ ప్రకాశ్ పక్క బిల్డింగ్. ప్రకాశ్ ప్లేస్ పక్క బిల్డింగ్ ఉంది కదా, కేఫ్ ఎక్లాట్. కేఫ్ ఎక్లాట్ అదే కేఫ్ ఎక్లాట్ బిల్డింగ్ థర్డ్ ఫ్లోర్. you want, we have converted everything into one column, minor editing. Home tab, conditional formatting, color scales, green, no, red, yellow, green. So all the greens are significant variables. All the greens are significant variables. So once you have created a column for your p-values, t-value undi kada, this is t-value. Okay, this is PR greater than t. PR greater than t untadi kada. Select the whole column, only numbers. Go to the home tab, conditional formatting, color scales. This one, red, yellow, green. Red is highest, yellow is lowest, green, yellow is medium, green is the lowest. So we have to redefine actually, or we'll do more rules. We have to redefine the rules. A text to column steer. See, that okay, you can do it later, not a problem. For us, it is predict. House, hey, we have not deleted the first variable. Our ID variable we have not deleted, right? That is the problem. We have not deleted the ID variable. A text file అయితే రన్ అవుతుందంటే అది అవుతున్నట్టు లెక్క. సింక్ తీసేయండి బెటర్. Summary house reg, plots, plot house reg. Residual sources fitted. Normal Q and Q, scale versus location, residual sources leverage. House test reg is equal to predict house reg, comma, house test here, square bracket -1. See, this is the problem. New levels came into the picture. So for predicting the data on linear regression model, you will get this error. New errors, new levels have been formed. So we have to go with the next model, decision tree model. All of you have run the regression model. Prediction will generate an error. So predict. Oh yeah, go. So on this you can try decision tree. Very well work. And you can upload the predictions also into Kaggle. Which graph? There are different graphs are there, not one. 4 graphs will come. Normal quiz shows whether it is normally distributed or not. It is not close to normal distribution. Yeah, all the things are closer to the red line, but the red line is not a straight line, it is slightly bent. So you can do decision tree. ఏంటి అది మోడల్లో తీసేయాలి మోడల్ బిల్డింగ్ ముందే తీసేయాలి So decision tree. Decision tree will give you the predictions. You can upload them into Kaggle also to check your accuracy. Or part. You want to see the important variables? Here you have very important variables on top. So these are the important variables. The overall quality is the most important variable, followed by neighborhood, followed by basement quality, garage cars, kitchen quality, garage area, air build, external quality, living area, foundation, air remodel. These are the important variables. Rest of all variables are insignificant variables. So 1, 2, 3, 4. 15 variables are significant. Rest of the 64 variables are found to be not significant by the decision tree.